a number. That looks good. 48. Let's do it. There we go. All right, number 48, condensing. So 3 things we want to look for to condense. First of all, can we move any powers that are down in front of the log up? Then if we have any addition, we want to turn that into multiplication. And if we have any subtraction, we want to turn that into division. Those are the 3 things, okay? So you want to make sure your final answer doesn't have any of those. And when we say addition and subtraction, we mean addition between logs and subtraction between logs. Okay, so in this problem, and I'll write a little bigger for you, 2 natural log x plus 1/2 natural log x squared minus 1 minus 1/2 natural log x squared plus 1. Do I have any numbers that I can move up into the exponent? 2 I can move up, so make it natural log x squared. Anything else? The 1/2s? When you put a 1/2 in the exponent, what does it equal? Same as a square root, so that's how we're going to write it. So it's going to be a square root over x squared minus 1 minus natural log square root over the x squared plus 1. That's why that parentheses is there to tell you what's going to be under that square root. And then this next step, you can actually do the last 2 pieces all at once. If it's addition or a positive term, it's going to go in the numerator. If it's subtraction or a negative term, it's going to go in the denominator. And we're going to condense it down to 1 natural log. Remember that log base, in this case it's a log base e, is never going to change. And I'm just going to make like a big parentheses, okay? If it's positive, it's going up top. If it's negative, it's going down below. So in my numerator, I'm going to have an x squared, and I'm going to have an x squared minus 1 under the radical, and those are going to be multiplied together. In the denominator, I have an x squared plus 1, and then no other terms there. And then that's as far as we can go with this. I have no other numbers out front I can move up. I do have addition and subtraction, but it's not addition between 2 logs or subtraction between 2 logs. So no other log properties can be used to condense. Any questions on that problem? All right. The next one is just the opposite. We are expanding. So we have the condensed version, and we want to write it out into the long version that has as many logs as possible. All right, pick a number, and I'll write it a little bigger for you. What do we like? 28. Okay, so I have log base 4 of x squared minus 9 over x squared minus 6x plus 8 to the 2/3 power. We want to expand. One thing I'm going to do here with my quadratics is I'm going to factor it, because then that allows me to split it up into smaller pieces. Do you know what x squared minus 9 factors to? X plus 3 and x minus 3. Okay, what about the denominator? Multiplies to 8 and adds to -6. -4 and -2. The first thing you need to do with this problem, I can't get to anything inside that parentheses until that 2/3 is gone. So if we're doing the opposite of what we just did in the last problem, where's that 2/3 going to go? If it's in the exponent, where can I move it? Down in front. So 2/3, and then I'm going to have all this stuff. Log base 4 of x plus 3, x minus 3, x minus 4, x minus 2. And all my parentheses and brackets there. Okay, so just bring that down in front. And now I can take all of those little pieces inside my log and change them into addition, if it's a positive term, if it's multiplied, and change it into subtraction if it's in a denominator. So here's what this is going to look like. The 2/3 is still going to be in front of everything. And then an optional step at the end is I could distribute that through. And then every log I create is going to be a log base 4. That log base never changes. So I'm going to have log base 4 of x plus 3 plus log base 4 of x minus 3. Both of those terms are in the numerator, so they're positive. the next two terms are divided in my log. So both of them are going to have a subtraction in front of them. So it's going to be minus log base 4 of x minus 4 minus log base 4 of x minus 2. And then again, an optional step is you could distribute the 2/3 through. It would be in front of each individual little log there. And then that would be really as far as you can go with it. We can't separate with those addition and subtraction symbols that I have inside the parentheses because they're in a parentheses there. Okay, if things were like multiplied or divided, if I had a product or a quotient, I could go maybe a little bit further, but addition and subtraction is not between my logs, can't do anything with it. Okay. Any questions? Yes.
On like the one that we condensed, why wouldn't we like multiply like the top, like the x squared, not x squared? Yeah. Oh wait, oh never mind.
So it's only because they're not both under a square root. If that square root wasn't there, sure, we could distribute the x squared through, or if they were both in a square root, we could multiply them together, but they're not really nice, pretty terms, so you can just leave it like that. Okay. Any other questions on expanding, condensing? All right, so that's the first two problems tomorrow. The third problem, even though it doesn't say so, will also be an expanding problem. So these are the ones that when we did them in class, I told you they were like hidden instructions. You need to remember the hidden instructions. So we have a log that we're supposed to evaluate given certain values, and you want to be able to plug these values in. The worst thing you can do in this problem is plug values in too soon. You must be expanded completely before you plug in anything from the given information. So pick a number first. 16. Okay. And before I even touch any of that stuff in that given paragraph, I'm just going to expand this as much as I can. So I'm going to have log of x squared. Okay, I have a log inside a log. And these are both log base 10. If you want to write that there, I'm just going to leave it as is, okay? So first, I'm going to just deal with what's on the inside of the parentheses there. How can I expand that? What could I do? I could bring the 2 down in front. Okay, so I have 2 times log x. Okay, and then this actually might be enough for me to be able to answer this question. We could even split it up a little bit. Well, maybe let's see if we need to split it up a little bit further. So log of x, at this point, you can go ahead and plug that in. What's log of x equal to? 2. That's given. Okay. And then at this point, I'm going to want to expand it a little bit further. I don't want to multiply that 2 times 2 because I don't know what the log of 4 is. That's not given to me. Okay, so expand it a little bit more. If it's multiplied, I can expand it into what? Addition. So I can make it log 2 plus log 2. And that's something that I know. The log of 2 from the given information is approximately 0.3. So 0.3 plus 0.3 gives me about 0.6 would be the final answer. Okay. Now that one's different than all the other ones up here because that was the only one that had a log inside a log. Maybe let's pick one more where we don't have a log inside a log, just so you have an example of each of them in your notes. 15. Okay. So I have log of the cube root of x squared y to the 4th. Okay, again, expand it first. If I have a cube root, that's the same as what exponent? 1/3. I'm going to bring that 1/3 down in front. Log of x squared y to the 4th. Okay, what else can I do to expand this? Okay, and they're multiplied, so when I separate them, it's going to become what, though? It's going to change the operation. It's going to become addition. Yep, so it's 1/3, and then it's going to be log of x squared plus log of y to the 4th. And there's one more thing we can do to expand this. What else can I do? I've got a couple more exponents now that I separated those I can bring down. So I have 2 times log x plus 4 times log y. Okay, and this is where I can just plug in my given information. So 2 times, what was log of x? Log of x was 2. 4 times log of y at the top is 3. And inside that parentheses is going to be a 16. I have a 12 and a 4. So times a third will be 16 thirds is my final answer for that one. And I would just leave it like that. Okay, so we're not really plugging in until that very, very end piece using that given information.
Why did you get a 3 from log y?
We were given that at the top. Yep. All right, so any other questions on that one? That was the last expanding problem. All right, next question. We have a system of equations with a log in it. Pick a number. 3. Okay, so we have log of xy to the 8th equals 32. And log of, looks like x over y under a cube root, so I'm going to say 1/3 power equals 2/3. Okay, so system of equations, this is going to kind of take a little bit of knowledge that you guys know from before about systems and incorporate it into our log problems. I want to be able to eliminate a term, either an x or a y. It's difficult to do that right now because there's so much happening. So I am going to expand just to separate my terms and get my x away from my y so we can eliminate something later. All right, so what can I do to expand the one on the left? Move the 8 down. And then because the x and the y are multiplied, I can separate that into what? Addition. So I can make it log x plus log y. And then you could actually at this point just make your life easy and just divide both sides by 8. So log x plus log y is 4. Okay. On the other side, I have a 1/3 power, very similar. I'm going to bring it down. So 1/3 log of x over y equals 2/3. Those numbers are divided inside my log, so I can expand it into subtraction log x minus log y. And then again, instead of distributing it in, if I want to make my life easier, I can just divide both sides by 1/3. 2/3 divided by 1/3 gives you what? Just 2. Nice and pretty. Okay, so this is a nicer version of our system now. And remember, we did systems. You have either elimination or substitution. Substitution is where you get a variable alone and then plug it into the other equation. That would be kind of messy with logs. So I'm going to use elimination. And if you notice, maybe if you write them on top of each other, it might be easier to see. We've already got opposite terms. We have one positive log y and one negative log y. So what should I be able to do? Just add them together. Log y's are going to cancel. Log x and log x give me 2 log x's. So I have 2 log x's equals 6. So log x is equal to 3. And what log base is this, by the way? 10. So can you tell me what x is going to be now? If I write with exponents, 10 to the 3rd is x. X is 1,000. Once we have one answer in a system, what do we do to get the other answer? Plug it back in. And you can use the final answer for x, but I'm going to actually use this. I know log of x is 3. So I'm just going to go back up here and say 3 plus log y equals 4. Okay, if you plug in 1,000, you do log of 1,000 and you get 3, but that saves me a step. So log of y equals 1. So can you tell me what y is going to equal? Again, remember it's base 10. Yeah, 10 to the 1st equals y, so y is 10. You can get some pretty big numbers here. Like if I have, I don't know, log base 10 of y to the 7th, it's possible you're going to get like 10 to the 7th power, or 10 million or something for an answer. Something really small if you have a negative exponent. Okay, but does that make sense? The first thing we did was just, again, expand until we can get to a point where we can use our elimination, cancel a variable, and solve for what remains. Yes?
We're plugging in the 3, right? So
Yeah, so you have two choices. I saw, okay, log x equals 3, and I've got a log x here, so I just replaced it with a 3. If you don't see that, you can just take 1,000 and put it in here, and do log of 1,000, and that would also just give you 3. So
okay. Just
just,
plug it in for either one.
and you can plug it into either one. So if I did, I could say log of x is 3 here. I would subtract 3 to the other side, so I have negative log y equals -1. So that cancel out my negatives, and I would get log y equals 1 there also if I plug it in.
How do you know 2 log x equals 6?
Because I added my like terms together. I have 1 log x and another log x, so I have 2 log x. These guys cancel when I add my equations together. 4 and 2 gives me 6. And then 5 by 2 gives me 3. Questions on that one? When you guys are doing the extra practice problems in Polaris, these 3 problems that are extra practice like this one are in a separate document in Polaris. You'll see it. It says like part 2 answers, and this is in part 3 answers. So if you realize like I'm missing the system ones, just look at the next document down. Everything was in there except for this one. Okay, really big numbers now. Write an estimate of each number in scientific notation and determine how many digits that number has. So these are the ones that are going to give you an overflow in your calculator. Pick a number. 49. Doesn't really matter. These are all pretty much the same. All right. And when we did this, we called the number k. So the property says we're going to do a log base 10 on both sides to start. Because base 10 is power base 10, what I want my scientific notation ultimately to be. So it's going to help me get there. If I have the log there, what can I do with the 500? Bring it down in front. And at this point, this is what you're going to type in your calculator. This was the problem, if you guys remember, we want to try to use that previous answer as much as possible. We practiced actually with the red calculator, so it's going to be a little easier with the graphing calculator now. We want as many decimal places as possible. So 500 log E, if I type that in, remember the E button's above the division key, I get 217.147241 is as many decimal places as my calculator is going to give me. We round that number up always. So 218 is how many digits we have. That's the first part of our answer. Okay. Now, to get the number in scientific notation, remember this log is a log base 10. Okay, so I have log base 10 of k equals all that stuff. Okay. So the next thing we do is write with exponents to solve for k. K equals 10 to this big power. All the decimal places. Then we want to split it into 2 powers of 10 to get our scientific notation. 1 power of 10 is the whole number, 217. And the other power of 10 is that decimal, 0.147241. The times 10 to the 217 is my answer. This other part, what you would do in your calculator, again, to give you as many decimal places as possible, I would take that previous answer and I would subtract off the 217. If you subtract off the 217, it actually gives you a few extra decimal places. Instead of a 241, I can say 09516 now. Okay. And then in my calculator, just 10 to that previous answer power. Again, so I'm really not rounding until the very end. And you should get 1.4035922218. Now it's important we have all those decimal places because this is a giant number. It is 218 digits, and we only have 10 digits of it. So there's still 208 zeros after it. So it's rounded significantly. Yes?
I did that. Your calculator didn't expand that very
So you typed it in and then subtracted 217 to the previous answer minus 217. That's why it's doing that. Okay, so just double checking your calculator. Are you getting that okay? Anybody need help getting all the decimal places? Yep.
This is a final answer, it's just 10, so like that decimal out.
It's that decimal, it's scientific notation. So it's a number between 1 and 10, which is what we have, times 10 to the 217. So it's that whole thing that I've got boxed in there.
All right, and you got that like final number, that's like 1.4, 5,
10 to this, which was the previous answer in my calculator. Yep.
How did you get the extra like decimals again?
So I have this answer in my calculator, and then I did minus 217 to take off the front of it, and that gave me the extra decimal places. So take off the 217 and then do 10 to that power. Still not changing. So, now, why yours would be different from mine? Okay. Questions? Yep. Okay. So you have to get that number in your calculator first. So you got to do 500 log E. Yep. That's the number. Take away the 217. So I'm not typing the number in. I'm just doing the previous answer. There's all those decimal places. And then 10 to that power. Yep.
And then times 10 to the 217.
And then you don't have to multiply. I mean, times 10 to 17. But you don't have to type that in.
All right.
If you type that in, that's why you rounded it right there. So what you want to do is type this 500 log E in again. Enter. Now minus 217.
Oh, you can't go up in it.
You can. Oh, that's why it's doing it. So sometimes it'll say A and S, but you got to type it all. So let's not do that. Let's do minus 217. There's all of them. Okay. Yeah, if you ever want the previous answer, if you're going up and selecting, another way to get previous answer is to hit second and then the negative key, and that'll insert whatever the previous answer is. So sometimes it can be tricky. All right, got a couple word problems. This one is one of our compound interest formulas. Make sure you know your PERT formula and your compound interest formula for tomorrow. Pick a number. 96? So we said? Okay. How long would it take to grow your investment from 10,000 to 120,000 at a rate of 10% compounded semi-annually? So if it's compounded any other way other than continuously, we're using our general compound interest formula, which is this guy. Okay. And then filling in what I know. So A is how much I end with. Do I know that here? Do I know A? Yeah, what is it? 120,000. P is how much I start with. Do I know that? 10,000. 1 plus, my interest rate is 10%. Move that decimal 2 spaces to the left, so 0.10. If it's compounded semi-annually, how many times a year is that? 2, and then 2 times the number of years, which is T, what we're solving for. Okay, so to solve for the exponent, I'm going to need a log at some point. We'll get there. If I'm going to solve for a log, you guys did this on the test yesterday, it's an exponential equation. You get the exponential part alone, the base alone, and then we take the log of both sides to bring the power down. So the first thing I'm going to do is divide by 10,000. I'm going to get that base alone. So I'm going to get 12 equals 1 plus, and I can actually simplify this a little bit. If I do 0.1 divided by 2, I get 0.05 to the 2t power. I could even simplify that a little bit more and just say 1.05 to the 2t power. And now because I have my base alone, I can take the log of both sides. And it doesn't matter what log you use, but I would stick with log base 10 or natural log because you've got those buttons. Okay. We take the log to bring the power down. So log 12 equals 2t times log of 1.05. And even though this looks kind of gross right now, log 1.05 is some number 2 also multiplied by t. So at this point, you can just do it all at once. You can divide by 2 in log 1.05. If you're doing it all at once in your graphing calculator, you either need to set up a fraction that looks like this, or at least put the denominator in parentheses when you divide. Okay? And then we're going to get t alone because my 2's are going to cancel. My log 1.05's are going to cancel. If you don't want to do it all at one step like this, you can just divide separately. Divide by 2, get an answer. Divide by log 1.05, get an answer. And then it's an interest rate, so I have an idea of what kind of number to expect with this. 2 times log 1.05. I get, oh no, it's not interest rate, it's a time. I take that back. To 2 decimal places, I get 0.465, so I'm going to say 0.47 time is years. So if I round to the nearest year, I would say 25 years. Okay, and then you can absolutely plug that back in and make sure it works as long as you've got it set up correctly. Questions on 16. Okay, 17 is a half-life question. Pick a number. 94. There are 2 half-life equations you need to know. Negative natural log 2 over k. And then the other one is a version of our PERT formula. A of t equals a sub 0, e to the kt power. When we did these in class before, we talked about you're going to plug everything you can into either equation. And how the process works is you're going to solve for k in one of the problems and then plug it into the other to get the answer to your question. But you need to know what everything stands for. So just like PERT, a sub 0 is what you start with. A of t is what you end with. K is your growth rate. In half-life problems, k should be negative because it's exponential dk. So k is always negative, and it's a decimal. It's a rate. T is your time, and then h is the half-life. So in this problem, it says we have 60 grams of magnesium 28. It decayed to 7.5 grams after 63 hours. What is the half-life? Okay, so I know stuff in the right side here. I know how much I ended with, 7.5, and I know how much I started with, 60. E is E. K, we don't know. We usually solve for K. And then T is our time, in this case, 63 hours. So if you look at this, this really looks like the problem we just did a second ago. It's the same sort of form. I'm going to divide by 60 first. And you can keep it like that if you want to keep an exact answer, or this one divides in pretty. 0.125 equals e to the 63k power. So I can take the log of both sides. I can bring the exponent down. In this problem, because it's a base e, what log might save us a step? If I do natural log of both sides, natural log of e to the 63k, natural log is log base e, and I have an exponent base e, so those cancel, and that leaves me with 63k equals natural log of 0.125, and then to solve for k, I'm just going to divide by 63. Make sure you end the parentheses before you divide. And I get about negative 0.033. I'll give it a few decimal places. And again, it should be negative, and it should be a decimal because it's a rate of decay. It's a percent. So now I'm going to use my half-life equation and answer my question. Negative natural log 2 divided by negative 0.033. And you just got to make sure you don't round too much. And I get about 21. So about 21 hours is the half-life of this element. Okay, so in this example, we solve for half-life, but again, you might be solving for the starting amount or the ending amount or the time. So it's definitely worth practicing a couple of these so you can see what it looks like when you solve for some different variables. Yes?
Are all the answers to like all the practice questions going to be on Blair's?
Not for these ones. You've got yours, and you've got 8th period. We'll also pick different questions. So that's a great practice test. And then for every one of these, I've got an additional 3 problems and answers online for you. So they're not like, I mean, some of them might be some of these questions that are like mixed in there a little bit. But other than this study guide, you've got 3 questions and 3 sets of answers for everything we're doing. Okay. Other questions on that, Ashley? Okay, last word problem I think is one of the easier ones of the bunch. Pick a number. Okay, 74. I have $10,000, interest rate 8%, compounded quarterly for 10 years. It's compounded quarterly, so again, we're using this formula. If it was compounded continuously, like this guy down here, just because we don't have it on there yet, that's where you would use PERT as a reminder. Okay, a little simpler version of it. All right, $10,000 is my ending amount. We're solving for the principal, how much we start with P. 1 plus my interest rate, 0.08. If it's compounded quarterly, how many times a year is that? 4. And then my exponent is 4 times number of years, 10. Now this one looks kind of similar to the other one we did, but we're not solving for an exponent, so your life is easier here. P is multiplied by that base to that power. So really what we need to do is just divide on both sides by that base, and you could say to the 40th power if you want to simplify it a little bit. On the right side, they're just going to cancel. And on the left side, that's what you're typing in. You can do it in pieces if you want, figure out what that denominator is, and then divide, or you could type it all in at once like this. Okay, let's see what you should get. And how many decimal places will we round to here? 2 decimal places. All right, and I get 4528.90 is my answer on that one. You can just double check you type that in, okay.
Why is it 10,000 like on the left? I thought it was like P like the original.
So in this problem, we are finding P, it says, and you're given that A.
Okay.
So here, we want to end up with a certain amount after 10 years, so we're trying to figure out how much do we want to invest to make sure that happens. So it depends how it's worded. You could plug in for either one.
Will it tell us if I P, or will it just say-
It'll say find P or find the principal, or find the amount you have to initially invest. It'll, yeah, be worded one of those ways. All right, last problem is a super quick one. You just got to remember your transformation rules. So we've got e to the x is basic exponential power function, and we want to name the transformations that make this different than e to the x. So left, right, shift, stretch, whatever. All right, pick a number. 84. Okay, the one thing I will say with number 84 is there's a couple things about this that look different than how we did our transformation charts in the past. So if you want to refer directly back to that, any number that's added or subtracted on when we did it, we put it at the end. So I'm going to write it like that. +3 instead. Okay. Also, the x was usually in front of the number. So I'm going to swap those out just to kind of visualize it a little better. Make it a -x +2 up there. Okay, so it's looking more like what we saw in our chart. The last thing is if you have something in front of your x, remember with our transformation rules, we want to factor that away from the x. So I have a negative there. I'm going to take it out. -x -2, and I factor it out. So I think this now makes it pretty obvious what the 3 changes in the function are. There's a negative inside the exponent. There's a -2 inside the exponent, and there's a +3 at the end. So those are the 3 things we want to address. What does the +3 do? Up 3. What does a negative inside the function do? Reflect over the y. Yep. And if you have a -2 inside the function, what does that do? Right 2. Okay. And so those are your answers. So just, you don't have to do any of that rearranging. If you can see it, great, but I think it makes it a little more compatible with our rules that we did before. If you do that, I think it's worth an extra minute to do. Okay. All right, that's our test tomorrow. So like I said, you're going to have these answers. You've got 8th period's answers I'll post also once that class period's over, plus an additional set of questions, 3 for each type. Remember, they're in 2 different documents in Polaris of problems. Then if you scroll down, the answer to go with that problem. So those are great to practice on your own studying tonight. And then nothing to worry about this weekend. On Monday next week, we'll get exam study guide, and we've got literally 6 days of exam review before your exam. We got a lot of time to prepare for that. So you can take the weekend off of math at least. Okay. All right, I'll do cell phone lotto. The last 10 minutes are yours.